Hello, this is Precalculus, and this is part 9 of the functions chapter, and this part covers piecewise defined functions. So a piecewise defined function is a function which splits a domain into several intervals or pieces, okay, using a different calculation for each interval. So in this example, we have f of x equals 3 when x is less than 2. F of x equals 2x plus 1 when x is less than or equal to 2, or greater than or equal to 2, and less than 5. So between 2 to 5, right? This would be negative infinity to 2. Put a comma there instead of, hang on, let me erase that. That would be negative infinity to 2, and this one would be 2 to 5, and this one would be 5 to infinity, right? So every time that x is more than 5, we're going to just use x. All right, so we need to find f of x of negative 6. So we need to figure out which one of these intervals negative 6 would fall into. So everything that's less than 2, it's going to fall into that interval. So if it's negative 6, if x was negative 6 is less than 2. So f of negative 6 equals 3. Okay. Next one, f of 2. So 2, if it's greater than or equal to 2, then it's going to be this function right here, which is 2x plus 1. So we're going to put x in there is 2. So if we've got f of 2 equals f of 2 equals 2x plus 1, we're just going to feed that 2 right into that where that x is. So 2 times 2 plus 1. 2 times 2 is 4, plus 1 equals 5. So that one's going to equal 5. 3. 3 would fall into this one right here, again, because it's between 2 and 5 right there. So the middle one is for all numbers between 2 and 5. So that means f of x equals 2x plus 1 if it's between 2 and 5, which it is. 3 is there. So we need f of 3, which would be 2 times 3 plus 1. That would be 6 plus 1 is 7. That one equals 7. All right, next one is f of 5. If it is equal to 5, well, there is none that's equal to 5. This is everything less than 5, and this is everything greater than 5. So 5 is not in the domain of this, so this is undefined. All right, because 5 is not on this graph for this function. There are no values for 5. All right, this last one is 7.123456789, and that would be greater than 5, because that number is greater than 5, so we need to find f of x equals, that'll be in this category right here, greater than 5, so f of x equals x. So if we're trying to find f of 7.123456789, right? Every time we have x, replace it with that. So it's just going to equal 7.123456789. And that would be the answer to that one. All right, so here's some explanations. It's greater than 5 for that input, f of x, so it equals 7.123456789. All right, the graph of a piecewise defined function is made up by drawing the graph for each separate formula, but only for the x values which the formula is used. This means we only use a piece from left to right of the entire graph for each formula, so we're going to look at that. All right, graph the piecewise defined function from the previous example. Alright, so if it's anything, so this first piece, we're going to say f of x equals 3. Right? And that's really the same thing as saying y equals 3. So no matter what x is, y is always going to be 3, but only if x is less than 2. So for all values that are less than 2, so right here, anything that's less than 2, y is going to be 3. Remember, when y equals 3, it's just a straight line on the horizontal. Alright, this next one is 2x plus 1. F of x equals 2x plus 1. Well, that is a linear function right there, so we know our, if we want to plot 2x plus 1, right, it's y equals mx plus b. That's our y-intercept, which is right here, right, and 2x plus 1, that means our slope is our rise over run, which would be 2 over 1. So we go up 2 over 1 to right there. Up 2 over 1. Up 2 over 1, so like right in here. So there's that. But it's only going to be if between 2 and 5. Remember, so we said between 2 and 5, so that's right there. Okay, and then this last part is y equals x, right? So its y-intercept will be at 0, and its slope is 1 over 1. So there, there, there. But that's only going to be for values more than 5, so that piece. So if we want to graph all these on one coordinate plane, it would look kind of like this. This is our first one where everything that is y equals 3, right? So this is our y equals 3, and this is only for values that are less than 2, okay? So it starts at 2, and we use an open dot right here, open circle, not filled in, because values less than 2, not equal to 2. Alright, and that keeps going forever in that direction. The next piece is 2x plus 1, so that'd be this piece. Right, and then this one is only for values between, that's greater than or equal to 2 up to 5, so 2, 3, 4, 5 up to right there, and that's an open circle because it's not equal to 5, it's just the stuff that's less than 5, and so that would be up 2 over 1, up 2 over 1, like that. So there's that one. That's terrible. Terrible line there. And then I think they did this last one wrong, because it is supposed to be everything that is greater than 5, and that's y equals x, and we're at 1, 2, 3, 4, 5. It should be an open circle right there, and go that way. Right, and then both of these aren't filled in, so I have to ignore that. That shouldn't be there. See if I can draw white. There we go. There we go. Fix that. Okay. Alright, so that keeps going in that direction, and you see how both of these are open circles because nothing is actually equal to 5. It's whatever's greater than 5, and this one is where it's less than 5. Alright, so pretty easy. You can a lot of times just figure out what something is from the graph. And then you can easily graph these functions. Alright, so this is what the homework looks like. For all of these, you're just going to feed these values into f of x or g of x. So I'll do one for you. If f of x is negative 6, so here's our f of x function. And if we had negative 6, which one of these functions would that fall into? This is x is less than negative 4. That would be in this one. So f of negative 6 is going to go into this function right here, because that's everything less than negative 4. Negative 6 is less than negative 4. Alright, so that means we would say f of x equals x minus 1. So if we're doing f of negative 6, that's going to equal negative 6 minus 1. Which would be f of negative 6 equals negative 7. So this one is negative 7. And I did these a little bit differently for the homework. You don't have to write this out on paper. All you have to do is type your answers into a Google Doc. So I have the whole thing set up for you on Google Doc. Let's try one of these g's. So let's try this one, g of 2. Alright, so right here, this tells us that if x is less than 0, our answer is 10. If x is greater than 0, our answer is greater than or equal to 0, x plus 2. Well, 2 is greater than 0, right? So we're going to be using x plus 2. So that means g of 2, we're going to replace our x with a 2 plus 2, and that means that would equal 4. So this one equals 4. Pretty simple. The next part, you have to match these to their graph on the next page. Alright, so this one is if x is less than 2, right, so for this part, we're going to say y equals 2. If x is greater than or equal to 2, y equals negative 2, right? So these are both straight lines, okay? No matter what x is, y is always negative 2, and no matter what x is on this one, y is always 2. So let's see if we can find that graph. That's got to be this one. Here's, I'd set negative 2 and 2. Yep. Nope, it's this one. There's negative 2 and 2. And this is 1, where the graph changes, right? So at 1. And that's where it changes at 1. So for that one, you would just write, or your answer would be, so that's your answer. So you just match each graph to its function. Alright, that is it for the lesson on piecewise functions. Thank you for watching.